Okay, so this is lesson 2, chapter 2, lesson 3, solving two-step equations. So we did one-step equations yesterday, and now obviously we're going to do two-step. We're going to, instead of just having one step to get to our x, we are going to have to do two steps, obviously, to get to our x or to our variable. So what this kind of entails is this right here. It's inverse operations. We're going to do order of operations in reverse. So the equation x divided by 2 plus 5 equals 11 involves two operations performed on x, division by 2 and addition by 5. So if we know what our x is, we know we're going to divide first and then add 5 to see if that equals 11. That's our order of operations. Okay, but to typically solve such equations by applying inverse operations, what that means is we're going to do the order of operations in reverse. So we kind of are going to basically undo what has been done to x. So here's what has been performed on x, and this is the order of operations that you would do. Once you know what x is, you would divide it by 2, and then you would add 5. That's our typical order of operations right here. This is our typical order that we would do this in. Okay, but the operations to isolate x are in the reverse order of operations. So we have to actually, instead of where they've added 5 to x, we have to undo it by subtracting 5 from both sides. And then we would undo the dividing by 2 by multiplying by 2. So that kind of makes sense. We're doing the inverse operations. So we would subtract 5 from both sides and isolate the division problem. Then we would undo the division by multiplication, which is the inverse of division. Okay? So let's just practice it. Kind of sounds confusing when we do it, but here's the actual problem. So here's our problem. So write your original equation on your notes. X divided by 2 plus 5 equals 11. And then we're going to subtract 5 from each side. That's how we isolate x, because this way the positive 5 and the negative 5 add to 0, leaving us with x divided by 2. So we always want to get our x term alone, whatever that is, whether it's 4x, 2x, just x, x divided by 2, 1/3 x, whatever it is, we want to get the term with the x in it by itself. And we've done that. We have x divided by 2 equals 6, because on this side, 11 minus 5 is 6. So now, to undo this division, we're going to do multiplication. So we're going to multiply both sides by 2, because if you do something to one side, you have to do it to the other side to keep that equation equal or balanced. And 2 and 2 cancel out, or they divide out to a 1, isolating us with this x. And so therefore we have x left on the left side, and we have a 12 on the right side. So x equals 12. So we've done two steps to solve for x. Or we've undone two steps, so to speak, to solve for x. So let's check it by substituting in the 12 for x, write original equation, substitute the 12 in for x, and now is when we would follow the order of operations. We don't have to undo it. Okay, we would follow order of operations. We would do 12 divided by 2 first, which is 6, and 6 plus 5 does equal 11. Okay? All right, so here's your guided practice. Each of these are two-step equations. Make sure you focus on the side with the variable, but go ahead and pause the video and do these three problems. Remember, we're going to undo addition and subtraction first, then we do multiplication and division. It's like we go backwards through order of operations. So pause and work. Okay, for number 1, you should have gotten an answer of 3. We subtract 9 from both sides, leaving us with 5x on this side, because these add out to 0 or subtract to 0. And 24 minus 9 is 15. And then we divide both sides by 5, giving us x equals 3. And if I need to write that out, I can. I will write out a couple of these. I won't write out every one. But my 5's divide out to 1, and 15 divided by 5 equals 3. Okay? My answer for the second one is 5. We would add 4 to both sides, giving us 4y equals 20. And then we divide both sides by this 4, giving us y equals 5. And if you don't understand that and you need me to work those out, I will work those out in class. And then number 3, on this side, we're going to add 7 to both sides. And we get 6 on the left. Our negative 7 and positive 7 add to 0. And we get z divided by 3. So when we multiply both sides by 3, we get z equal to 18. And you should put those in and always check your solutions. I'm not modeling that now for time on the video, but you should always check your solutions. Plug your answers back into the x and solve. For example, 3 times 5 is 15, and 15 plus 9 is 24. These equations are actually simple enough that you should be able to do just a mental check in your head. All right, solving a two-step equation by combining like terms. So this time our step is going to be looking at things that are the same that we can actually add together. The 7x minus 4x, we can combine these, we can add them or subtract them because their variables are identical. You can only do that if the variables are exactly the same. One can't be x and the other one x squared. One can't be x and the other one be y. If their variables are identical, then you can add or subtract the coefficients or the numbers in front. Okay? So in this case, our x's just kind of go along for the ride, and we do 7 minus 4. And 7 minus 4 is 3, and that's our combining like terms. 7 minus 4 is 3. Our x just goes along for the ride, just rides along. So now we have 3x equals 21. So obviously we're going to divide both sides by 3. Okay, when you divide both sides by 3, your 3's divide out to 1, isolating that x. And 21 divided by 3 is 7. So x equals 7. And we could put that back in, and we could check. Let's go ahead and check that. I thought maybe the video would do it, but let's check it. So we have 7 for x, so we have 7 times 7 minus 4 times 7 equals 21. And we're going to make sure that checks out. Okay, 7 times 7 is 49. 4 times 7 is 28. And 49 minus 28 equals 21. So our solution checks out. Okay, always good to check your work. All right, example 3. And don't forget, you can always rewind, and rewatch any part of this video if you don't understand it. Rewind it, listen to it a second time, see if it makes more sense the second time. And you can always bring questions to class. Write questions down if you have them so that you don't forget. All right, here's example 3, finding an input of a function. All right, the output of a function, so underline the word output, of a function is, underline the word is, 3 less than 5 times the input, and underline the word input. Find the input when the output is 17. So they tell us what the output is going to equal. So we're going to need to have this information right here in just a second. So let's think about what it's asking us to do. Okay, we're going to write an equation. We don't have an equation, so we're going to write an equation for this function. X is always our input, so I'm going to put an X right there. And Y is the output, so I'm going to put a Y right there. And I'm going to kind of use this as a verbal model. So my Y is my output. So my output is means equals. Here we go. Y is means equals 3 less than. Now I have this underlined and italicized because this is the one that means we actually are going to flip-flop these around. 3 less than this. So there's my output, here's my equals, here's my multiplication, and here's my input, and there's my numbers that go. So there's my verbal model. So there it is. My output, y, equals 3 less than 5 times x. So we've written it. Now we have two variables. We can't solve an equation necessarily with two variables. You can't solve for x if you have a y. But it says, find the x when the output is 17. So we're going to substitute 17 in for y because we want to find what x will be when y is 17. So step 3, we're going to write our original function, y equals 5x minus 3. We are going to substitute 17 in for y, and now we have a simple two-step equation. So we're going to add 3 to both sides. My negative 3 and positive 3 add to 0, and 17 plus 3 over there is 20. So we have 20 equals 5x. Divide both sides by 5. My 5's divide out to be 1, isolating x. And 20 divided by 5 is 4, so therefore x equals 4. Okay? And we check it. Put your 4 back in for x. 5 times 4 is 20. 20 minus 3 is 17. So that would be my output. When x is 4, my input, 17 is my output. Okay? So an input of 4 produces an output of 17. And then, oh, we've already checked, but we'll check it really quickly. Put your 4 in for x and your 17 in for y. Put a question mark to see, but we already know it's going to check out. 20 minus 3 is 17. 17 does equal 17. It checks out. Okay, go ahead and practice. We have a couple guided practice problems. I'm going to go ahead and let you pause the video and do 4 and 5. Combining like terms. Okay, for 4, you should have come up with 4. If you did not and you don't understand why, go back and work it out and see if you can come up with an answer of 4. And then for number 5, you should have an answer of 7. If you didn't come up with that, please go back. Remember, we only add or subtract the coefficients. So 4 plus 2 is 6w, and 8 minus 3 would be 5t. So just keep that in mind. Okay? All right. Here's some guided practice. Output, remember, is your y. There's your equals. Your input is going to be your x. So find the input when your y is 11. Okay? So I'm going to go ahead and help you write this equation, just this one, and then you're going to do 7 by yourself. So down here we're going to have y equals, y is 5 more than, so 5 plus, negative 2 times the input, which is x. Now we don't need the parentheses. I just wasn't sure what we were going to be multiplying it by, so I just put the parentheses to be safe, but it does represent multiplication, but you don't have to have them. There's your function. So now substitute in 11 for y and solve. So solve for x. So subtract 5 first. This is a positive 5, so you'll do a negative 5, and then you'll divide by negative 2. Okay? I should technically have parentheses around that because of that plus sign. All right, you should come up with an answer of negative 3. And when we check it, negative 3 times negative 2 is positive 6, and 6 plus 5 is 11. So you do number 7. Go ahead and write your function, and then substitute 3 in for y, and solve for x. And you should have come up with 1 3/4, or you may have come up with 7/4. Okay? And if you do come up with a fraction, leave it in fraction. I don't want to see this. I'd rather not. Okay? If you're dealing with just numbers and you come up with a fraction, leave it alone. Don't necessarily change it into a decimal. Only use decimals if your problem starts out with decimals. Just generally for solving equations. That's a general rule. All right, and then the last problem, again, this is not a function, but this is writing an equation, just an example of writing an equation. Kim has a job where she makes $8 per hour plus tips. Yesterday, Kim made $53, 13 of which was from tips. How many hours did she work? Okay, so let's think about this. The money Kim makes is my y. That's my dependent variable. It depends on the $8 per hour that she works plus tips. I'm kind of writing a verbal model at this point, plus tips. Okay, we know what the tips were. We know what her total money is. Maybe I should have written a verbal model. Total equals $8 per hour plus tips. There's my verbal model if you need that. That's maybe a better way to write it. And my total dollars is my y. My independent variable would be how many hours I work, because that's what we're looking. How many hours I worked. I'm saying me because it's Kim. Sorry. How many hours Kim worked. All right, so my tips, there I did it again. Tips are $13. Total money made is $53. So let's substitute those in. $53 equals $8 per hour plus the 13 in tips. You solve that. Find out how many hours Kim worked. Bring that answer to class. That will be your homework check, is to bring this answer to class of this problem. And that's the end of the video. See you tomorrow.